Welcome to another Techstination interview. I'm Fred Fishkin, and joining us is quantum physicist by day, father by night. I'm stealing those lines, and author of so many books for kids and grown-ups, Chris Ferrie. Hi, Chris.
Thanks for having me, Fred.
In addition to all of that, you're also an associate professor at the University of Technology, Sydney, and that means Sydney, Australia. So good day, if I'm saying that right.
Yeah, you might tell from my accent that I'm not originally Australian, but yeah, I can appreciate good day.
Well, tell me about the approach you take. If people have not seen your books, and there are dozens, I think more than 50 at this point, and you take a very unusual approach to introducing kids, young kids, to topics that grown-ups may say, wow, you're going to give that book to a child based on talking about quantum physics for babies. Tell me about your approach here.
Well, I guess there's a few ways to think about it. One is when I originally started, I wanted to write a science book for my own children, but I didn't know what topic to choose. And so I chose my area of research, which was quantum physics. And it kind of spun out from there. But as I was doing it, I thought, what are the reasons that this doesn't exist? And I think one of the reasons is that people are afraid of these topics. They think it's too complicated for them. And if it's too complicated for them, then they're definitely not going to take the responsibility of having to teach it to their own kids. So what I wanted to do was bring what seems like the most complicated and esoteric topics in science, and well, in all areas of human intellectual endeavors, and just show that these aren't so difficult. Yeah, they're couched sometimes in jargon and in words that the gatekeepers like to like to use, but really the concepts can be phrased in a simple way that even children can understand.
And while they're labeled, many of the books are at least for babies, we're really talking about I think probably a couple of years old up to 7, 8, 9, maybe beyond even with some of these.
Yeah, I mean, it's a picture book. So I think you can read any book with words and pictures to newborns. They just want to hear their parents' or grandparents' voice and, look at things. So of course, the babies don't know, right? You show them a book with quantum physics. It's not like they know that that's supposed to be complicated. They just want someone to read them a book with enthusiasm. So, yeah, a baby obviously isn't going to understand, the concepts in the book, but a baby also isn't going to understand shapes and colors and things either, right? So I think anywhere where you read a book to children, you can read these books as well.
And I suppose one of the things that it does is take, and sort of alluded to this, some of the mystery out of these words and phrases here, like talking about quarks and so many other things here. It's another title, General Relativity for Babies, Electromagnetism, blockchain for babies. Tell me, I don't know much about a lot of these things for sure. So tell me about what you want families and children to get out of these books.
I think the first thing I want, and if I get this, I'll be happy, is that people who would otherwise shield their kids from these topics because they themselves think that it's too complicated. So let me give you an example. There was a situation I remember picking my kids up from school, and one of the other parents was, consoling their kid who didn't do well on a math quiz or math game that they played. And I could see on the parent's face actually a sigh of relief that their child wasn't a math person in their mind. And that was a good thing because they themselves consider themselves not a math person. They would say they hated math in school. So now they don't have to worry about this child being interested in math and bringing up this topic of math all the time. And that, as a mathematician, broke my heart, obviously. And it's a sort of, these are the sort of situations that I want to avoid. I want parents who maybe, didn't get the best education and are somewhat traumatized by their education in math and science to be reminded that, that was just a fluke and an accident. Unfortunately, that happened to them. And it didn't have to be that way. And it doesn't have to be that way for their own kids.
That's interesting because I guess it's a comfort level, and it's a great story about the parent being afraid of having to deal with maybe or trying to explain math problems to their child. But today there's so much help online too. We can all turn to, I suppose, as well, right? So if we take a look at these titles, and as you mentioned, there are dozens in all. How do you decide what you're going to write about next?
When I started, I wrote about the things that I was interested in, my areas of expertise, which, for math and physics. And then I initially started as a self-published author. So I published them myself. And then I got connected with a publisher, and, they have a huge team of marketing experts. And so they can gauge the market to see what people want and what people are interested in. And so they can see through the data that they collect that maybe electromagnetism isn't so popular, but blockchain is popular. And you'll notice that the books that aren't in my area of expertise, I typically co-author with another expert. So many of the books now are co-authored because, through conversations with the publisher, we decided that would be a good topic to add to the series. And either I knew an expert, or they sought out an expert, or an expert approached them. And then we get together and write the book together.
And you did partner with one book that's not in the for babies category. You have one called Prank Lab, 25 hilarious scientific practical jokes for kids. I imagine that could be popular in a certain age group.
Yeah, that one's a bit dangerous. A few science teacher friends of mine, we got together and, we're kind of, joke around with each other a lot. And, they know what's engaging for children because as teachers themselves. And I thought, there's a lot of popular things on, say, social media and TikTok are these, short, explosive science videos and pranks and things. And I think, especially for science, it gives not a great impression of what science is. So if a scientist goes on, some morning show, they're going to do the elephant toothpaste experiment where things just explode and the host gets all excited. And, that gives a really, really incorrect view of what science is. So we thought, let's take these things that kids are interested in, and kids are interested in jokes and pranks and things, and really explain the scientific concepts behind them, and how you can how you go about figuring out why that works as a good prank, and how you could modify it yourself or create your own pranks based on those concepts of science.
That's interesting. Do you have any particular favorite pranks from the book that you can recommend?
There's some really, really simple ones. There's a lot of things you can do if you can get your hands on a strong magnet. I'm not sure, like, locally where you can find them. There's like science shops around here. Of course, you can always order them online, but you want the rare earth magnets. They're the really strong ones. I mean, probably most people have seen them. If you get a really good fridge magnet, if you get a bad fridge magnet, it won't hold up paper. But if you get one that's really good, it probably has one of these rare earth metals in it. So you get a couple of those, and you can do some really fun stuff. So one is you put one on the bottom of a coaster, and you tape another one to the bottom of the cup. So when you bring them together, the cup won't fit on the coaster. So you got to be careful about, we'd be yeah, each prank comes with a warning. And a lot of the required materials include a towel, and you're responsible for cleaning up afterward. So yeah, so there's a lot of fun stuff you can do with a magnet. So if you pick up the book, grab yourself a magnet. There's a lot of good pranks in there around the use of magnets.
That go beyond the vinegar and baking soda volcanoes that we all have made. Kids.
Right, right, right.
So you've also turned your attention, I think, pretty recently to us grown-ups with a title called "Where Did the Universe Come From?" and Other Cosmic Questions. And you have a co-author on this. Tell me about it.
Well, this book, so the co-author is Geraint Lewis, and he's a cosmologist. So he looks at the big stuff in the universe, the expansion of the universe, things like dark energy, the stuff that we know is there, but we don't yet have an explanation for. He looks at this really big picture stuff. And as a quantum physicist, I look at the really small stuff, microscopic, beyond microscopic stuff we can't see, even with our microscope, so we can't see with our eyes. And often these two things are told with different stories, and it gives the perception that there's like two branches of physics, and they're just two separate things. But really, our understanding of the universe is based on the marriage of these two big concepts in physics. So things like the Big Bang, which everyone's heard about, whether it's watching documentaries or popular TV shows, that idea wouldn't have happened if we didn't have quantum physics and cosmology, which is based on Einstein's theory of relativity. So the book goes through the history of the universe and how we understand all of these things about the universe as a sort of combination of cosmology and quantum physics.
And for a lot of us, when we start reading about things like this, and I've gotten into the book some so far, wrapping your head, I guess that's a phrase you hear a lot, wrapping your head around some of these concepts isn't so easy when you start talking about quantum physics, is it?
Yeah, it takes time. I mean, Geraint and he's a bit older than me, but let's say me, I spent 15 years, 10 hours a day for 15 years. I mean, if you spend that much time on anything, right? I look at what my mechanic does, and it boggles my mind. How did you know how to do that, right? And it's because of practice, right? So if you're good at something, it's because you practiced it. Sports athletes, look at them. They practice all day, all night, and that's why they're good at it. But I don't want to, sports and say music are great examples where the people that are performing it obviously spent a lot of time. And if you want to do that, then you have to put in the time and practice. But at the same time, there's a whole audience, there's an auditorium full of people that can appreciate what they do. And I think that's the big problem, especially with quantum physics, is like we don't have anything to show the audience. We have these people, they sit behind, in offices typically now with glass walls and a whiteboard, and it's not a good show. We don't put on a good show. So writing these books is in some sense my way of trying to find out how people can appreciate it on the same level that people appreciate music or sports or say even tasting wine. I don't know if you're a wine or aficionado, then you watch people taste wine and then you taste it yourself and you say, what the heck are they talking about? I don't get all this stuff. So, but there's a level of appreciation you can have for all of these things, and that's what we want to bring to science. That the idea that you can appreciate it without having to spend the 15 years studying it.
And you do such a wonderful job in making it approachable and not intimidating for people, and helping us all to try to understand things a little bit better. And in the end, why do you feel it's so important for the general population and not just the physicists like you to to have at least some kind of basic understanding of this?
I think for me, I when I look at my understanding of science and all the sort of training and practice that I put into it, I really feel lucky when I look around at the world and I see just how complicated and complex it is. And nowadays, with so much information that's being presented to us, and my training in taking complex problems and simplifying them and trying to find a way to work with them allows me to just navigate this complex world that we live in. And I think that's one of the most important things I think parents and young people need to understand, is that as complex and complicated as the world seems, there are ways to deal with it. And that is, that there's people have figured this out, and it's science and engineering. And that's how they can deal with all of this complexity. So, the more time you spend with it, the better you get at it. Every little bit counts. So it's not like you have to put in 15 years and then there's like this, aha moment, you get your degree and then you can do it. Every little bit helps. So I think for me, that's the most important reason that that people need to understand that in this age of information, that there is a way. We figured out a way to tell truth from untruth, and it's science.
And one of the things that you ask here is, what is left for humans to discover? And I guess my answer would be, we don't know. We don't know what's left for us to discover. But how would you answer that?
Well, I mean, I like your answer. Yeah, your answer is great. There's a great quote. I think it's from John Wheeler, a famous American physicist, and he said that he likened our understanding to an island, right? And island is our knowledge, and there's a shore of ignorance. And as we learn more and more, we grow the island, but that means the shore grows as well. So what we see that we don't know grows as our knowledge grows. But also there's just this vast ocean that in some sense we'll never know. So there's every time, we come up with a discovery that opens, 10, 15, dozens of more questions. And so we know that there are things out there that we have yet to understand. Famous ones now are dark matter and dark energy. But beyond that, again, we don't know. Once we figure those out, there'll be more questions. It's unending, right? Yeah, it's exciting. I mean, people love exploring. So, a lot of our stories are about, ancient explorers, and it's very easy to visualize, right? We had a map and there was an empty part of the map. And so somebody goes to that empty part of the map and says, oh, there's an island there, and I've discovered it, and I'm an explorer. And it seems like now we've got every inch of the globe mapped out, so you can't be an explorer anymore. But that's not true, right? The exploration was always in revealing where our ignorance lies. And so you can be an explorer. You can be an explorer, and you'll be an intellectual explorer. And the tools you need to do that, are science and critical thinking and abstraction and a bit of mathematics. And yeah.
Terrific. What's next for you on the book front or other fronts?
Yeah, always writing books. It's still sort of a hobby that I do in my spare time. My primary job is as a professor at UTS, and I have a research group, and so that's always what I've been passionate about is research. So that'll occupy most of my time. And I like teaching. I like training young people. I like seeing those aha moments. So yeah. we'll just keep going at the pace we're going, and see, we'll take what comes.
Terrific. The website is csferrie.com, csferrie.com. Chris, thank you so much for spending time with us.
Thanks a lot, Fred.